Hello everyone, my name is Zhuo and the title of my speech is an improved method for Chinese relationship extraction. Next, I will be presenting the following 5 areas, namely introduction, method, dataset and experiment, result, conclusion, and future work. First is the introduction model. This paper deals with the area of Chinese relationship extraction, where a pair of entities is identified from each text of a given dataset and the relationship between entities is identified. In simple terms, a sentence is input and all the triples contained in this sentence are output. As a highly valued aspect of information extraction, the text of relation extraction is a problem that has been extensively studied and improved by scholars worldwide. At the same time, the role of Chinese relation extraction for downstream tasks, such as the construction of subsequent semantic knowledge bases, has also become more and more important. Compared to relationship extraction in other language aspects, Chinese relationship extraction has specific characteristics and difficulties, mainly in the following aspects. The first point is that the boundaries of Chinese words are difficult to define, and the problem of nested entities can arise, which in turn can cause many word ambiguity problems, and to a large extent depend the difficulty of identifying Chinese relations for extraction. The second point is that due to the characteristics of Chinese, long and difficult sentences are common, so that trigger word extraction in Chinese is more difficult than in English. The third point is that word or phrase in Chinese will often represent more than one meaning. The fourth point is that in Chinese relationship extraction, there is sometimes more than just one relationship between the subject entity and the object entity. In response to the above problems, the following contributions are made. Firstly, the last 4 layers of robot, which are more suitable or textual tasks, are fused for encoding. Then the concept of joint-level relation extraction is adopted, and the sequence annotation is abandoned in favor of point annotation to address the problems in Chinese relation extraction in a targeted manner. A network structure called RSO is proposed overall for Chinese relation extraction. The next point is the method. First is the overall model diagram proposed in this paper. Divided into 3 parts, from top to bottom: the encoding model, the subject-entity extraction model, and the object-entity extraction model. In brief, in the encoding model, we use the fused 4 layers robot to encode the vectors. In the subject-entity extraction model, use the point annotation concept. The subject entity in the corpus are extracted according to the encoded vectors. In the object entity extraction model, cascaded point annotations are used to predict the object entities corresponding to the subject entities in each class of relations. Firstly, in the encoding model, the pre-trained robot model is used and fine-tuned, and the fused 4 layers robot model is used for encoding. Each word in a given corpus is encoded to generate a 3072-dimensional vector for subsequent tasks. The robot model has the following advantages over the bot model. Fine-tuning robot on task will have an impact on the experimental results, as the results obtained from different layers of the pre-trained model often represent different syntactic and semantic information. Chinese relation extraction is also a type of text-based task, and showing different layers of pre-model for encoding has different effects on the task. Fine-tuning the robot model can better apply the robot model to a Chinese relation extraction task. Next model is the subject entity extraction model, a step that focuses on identifying all the subject entities presented in the given corpus. In this model, a point annotation framework is used to identify the subject entities by annotating the hand position and tail position of the subject entities that may be presented in this sentence. It is divided into two lines. The first line identifying the beginning of the subject entity, and the second line identifying the end of the subject entity. If the word is the beginning or end of the subject entity in the corresponding line, then the corresponding position is 1. Otherwise, it is indicated as 0. The last model is the object entity identification model. This step is to determine for each relationship whether there is an object entity corresponding to an identified subject entity. A cascading point annotation framework. Again, each relationship is divided into two rows. The first representing the beginning of the object entity, and the second representing the result of the object entity. Firstly, this paper reused the vector generated by the encoding model fine-tuned robot and sums this vector with the encoded representation of the subject entity identified in the subject entity extraction model. This is then fed into the object entity extraction model. The relation extraction experiments in this paper were trained and tested on the dataset of the Baidu 2020 relationship extraction task. The dataset has a total of 54 relationships. This relational extraction experiment pros to use P, R, and F1 values to evaluate the results of this model against other comparative models on the Baidu relational extraction dataset. The proposed model is compared with other baseline models with different batch size. The first group used batch size 8, and the second group used batch size 16. As can be seen from table, with the batch size 8, RSO model achieves better results compared to the control models. The FE value of RSO is 65.40 compared to 63.66 for the casserole model and 64.27 for the TP-Link model. The F1 value of RSO is 1.74% higher than that of casserole model and 1.13% higher than that of TP-Link model. When the batch size is 16, this model also achieves better results than the comparison models. The comparison is even more pronounced when the batch size is increased. In this paper, the problems of Chinese relation extraction are addressed. Firstly, the joint level extraction method is used instead of the pipeline level extraction method to avoid a series of problems such as error accumulation. In addition, the last 4 layers of robot model are fused in the encoding part to improve the encoding effect. Finally, point annotation is used instead of the sequence annotation, and cascading point annotation is used in the object entity model to effectively solve the difficulties and problems in Chinese relation text extraction. Overall, under the condition of enhanced word encoding, Object entities corresponding to the extract subject entities are predicted for each relationship. Experimentally, excellent results were achieved on the Chinese relationship extraction dataset compared to the control model. The impact of adding word vector features to the coding layer vectors or adding attention to the combined parts of the coding layer vectors will be investigated in the future. Thanks for your attention.